Josh here again. In today's video I'll be discussing random access files and how to implement them properly in Java. Enjoy! So what is a random access file? Unlike sequential access files, which are opened at the beginning and advance sequentially as data is read, random access files can be used to jump to any location in a file without needing to read the preceding data. Think of them sort of like a CD. You can skip to the next song on a CD without having to fast forward through or listen to the one before it. To create and work with random access files in Java, you use the random access file class, which is located in the java.io package. There are two different modes for random access files, which are specified by the second argument. And R opens up the file for reading, and RW opens up the file for both reading and writing. A file that is opened or created with the random access file class is treated as a binary file. The random access file class actually shares the same methods as the data output stream class and the data input stream class, which we used in the object serialization and binary files videos to read and write data. Here are some of the more common functions used to write data with a random access file. Since the descriptions provide an adequate explanation of the methods, I'm going to move on, but feel free to pause the video here to look over the methods and descriptions. Similar to the last slide, this slide contains information regarding the methods used to read data from a random access file. Once again, feel free to pause the video and look over these before moving on, and don't fret as there will be examples using some of these methods later in the video. So, by later, I actually meant now. In this first example, we're going to write the alphabet to a random access file for later use by a reading example. The first thing I did was created a character array containing the alphabet. Then, I created a new random access file object, randomtest.dat. Notice the second argument, RW, implying that this file is open to be both read and written to. After that, I use a for loop and the random access file class's writeChar method to write each letter to the file before closing the program. Now, when I open the randomtest.dat file, you'll notice that just as with binary files, you cannot view the contents as you would a normal text file. Before we move on to reading from files, we first need to discuss the file pointer. The random access file class treats a file as a stream of bytes. The bytes are numbered from 0 to the last byte's number minus 1, similar to array subscripts. Internally, the random access file class keeps a long integer value known as the file pointer. The file pointer holds the byte number of a location in the file. When the file is first opened, the file pointer is set to 0. When something is read from the file, it is read from the byte the pointer points to. After a value is read from the file, the pointer is incremented by the amount of bytes taken up by the value. For instance, if an integer is read, the pointer will be incremented by 4. Writing also takes place at the location pointed to by the file pointer. If the file pointer points to the end of the file, then the data will be written to the end. However, if the pointer holds the number of a byte in memory where data is already stored, then the existing data will be overwritten. Not only does the random access file class let you read and write data, it also allows you to move the file pointer. This means that you can read data from any byte location in the file. To move the file pointer, use the seek method as shown below. This command moves the file pointer to byte number 30, which is the 31st byte in the file, and reads the byte stored there. Before we move on to the second part of the example, I'd like to discuss an important detail that you should keep in mind when working with random access files. Random access files only recognize a series of bytes and do not differentiate between integers, characters, etc. Because of this, you should always remember that it is your responsibility to know what data type is stored in each byte of your file. For instance, if you store a character at byte 6 in a file and then call the readInt function, you won't get an error, but you might not get the results you expected. Alright, so in our second example, I'll be demonstrating seeking and reading from the file we created earlier in the video. I start off by opening the randomtest.dat file for reading only. Then, I seek to the 8th byte and print the character found there, which in this case should be E. I then move on to byte position 24, which should be M, and byte position 40, which should return U. Now in the last part of the code, you can see that I seek to position 19. Since characters only take up 2 bytes, position 19 will be in the middle of one of the characters. So what sort of output will we get? Now you can see that when I run the program, we do in fact get E, M, and U with our first 3 calls. However, my last call, the one we were unsure of, yielded a question mark, certainly not what we were looking for. You should always be sure to keep this in mind when working with random access files. Well, that wraps up another video. As always, feel free to post any questions you might have in the comments section below, and be sure to subscribe if you'd like to be notified when any new videos are posted. Thanks for watching.